Hello everyone. In this video, let's discuss how to write a program to design circular DQ. So let's discuss about DQ first. So DQ is nothing but double-ended queue, which means insertion and deletion can happen at both the ends. In a normal queue, insertion happens at the rear end, deletion happens at the front end. But when I go for DQ, that is double-ended queue, insertion and deletion both happens at both the ends. Design your implementation of circular double-ended queue DQ. Implement myCircularDeque class. So here they have given a class called myCircularDeque. We have to implement this particular class. First, myCircularDeque int k. So this is a constructor. We have to initialize the DQ with the maximum size of k. Next method is insertFront. We have to add the element in the front of the DQ. We have to return true if it is successful, else false. Next, insertLast. We have to add an element at the last of the DQ. We have to return true if it is successful, else false. Next, deleteFront. We have to delete the front element of the queue. We have to return true if it is successful, else false. Next method is deleteLast. We have to delete the element at the last and we have to return true if it is successful, else false. GetFront. We have to get the front item of the DQ. If the DQ is empty, we have to return -1. Next, getRear. We have to get the last element of the DQ. We have to return -1 if the DQ is empty. If isEmpty method, it helps us to know whether it is empty or not empty. isFull method helps us know whether it is full or it is not full. So these are all the methods we have to complete. Let's start one by one. First, myCircularDeque. So here we have to initialize the DQ. First, let me declare int a. So I have declared this. Now I'll initialize this. A equal to new int of k. Fine. Here I'm going to take 4 variables. So first one, to insert in the beginning and delete in the beginning. For that I'll take a variable called head. Similarly for the rear end, that is tail, I'll take insert at the end, delete the end. So this will be taken care by a variable called tail. Then to know what is the size of the queue, current size of the DQ. For that I'll be taking a variable called size. And the next one is nothing but capacity, to know what is the actual size of the DQ. Now we have to initialize those values. So head, so it starts with the index value 0 because in the beginning, right? So I'll give the value as 0. Next, tail. So tail means I have to insert or delete at the last. So size -1, that is k -1. Fine. Next is size. Initially the size of the DQ is 0. Capacity. What is the actual capacity? That is 3. So I'll take the variable k. That's all. I have initialized the values. Next, here I'll take 3. This is the actual array. Okay. Now we'll visualize the elements. Index value is 0, 1 and 2. So here we have to take variable called head. The value of head is 0. Next, tail. So tail is 2. Next one is size. Size is 0. Next one is capacity. Capacity is 2. Just cut this a little bit here. Yeah. Fine. Done. Next, insertLast. So I'm calling a method called insertLast. So this is the method I'm going to go for it. The value they have passed here. So I'm going to insert the value called 1. Fine. To insert element at the last, first I have to check whether my DQ is full or not. If my DQ is full, I cannot insert the element at all. So for that, I'm going to call a method called isFull. So I have called a method. So let me complete that method. So isFull. How come I can know whether my DQ is full? I have to check whether the size value is equal to capacity. If size and capacity are equal, we can say that DQ is full. So here size value is 0 and capacity value is 3. So both are not equal. So what I'll do? It returns false. So I'll go here if condition is not true. In case if it is true, I'll return false saying that insertion is not possible. So here the condition becomes false. So I'll go to else part. Now I'm going to insert the element at the last. So if you want to insert the element at the last, I have to take tail is equal to tail plus 1 divided by capacity. So what is my tail value? Tail value is 2. 2 plus 1, that is 3. 3 modulus 3, 0. Why we are giving modulus capacity? Because it's a circular DQ. That is why I am giving modulus the actual size. So on the index value 0, I'll insert the value called 1. So here we are inserting at the last. Okay, so I'm inserting at the last. This is just pictorial representation. This is with array index value. So I'm inserting the value called 1 at the last. I'll write it here. Array. Just a representation I'll mention here. Because whether we are inserting the beginning or at the front, we have to know that. Okay, fine now. So this is done. After this, I have to store in that index value a of tail. So a of 0 is equal to value. After that, size value will be incremented because now I have an element in my DQ. So size value has to be incremented and then I have to return true. Okay, so size value from 0 it is incremented by 1. Done. Next, after this I'll return true. So I have got true here. Now I'll go for the next element. insertLast. So I'm trying to insert the value called 2. So again I'll call the same method. Now the value is to check whether my queue is full. I'll go to this method. Size is 1, capacity is 3, 1 equal to 3. No, it returns false. So it go to the else case. Tail equal to tail plus 1. So tail value is 0. It has changed. Fine. So 0 plus 1. It is 1. 1 modulus 3 is 1. So 0 plus 1, 1. 1 modulus 3 is 1. So on the index value 1, I'll insert the next element called 2. I'll insert the next element called 2. Size will be incremented by 1. Size will be incremented by which becomes 2. So here I am trying to insert at the last. So when I try to insert at the last, so here 1, this will be 2. This will be moved because I am inserting at the last, right? So this is representation. Done. After that I'll return true. So this true will be returned. Fine. Now I'll go to the next one. insertFront. insertFront. Now I want to insert the value called 3 at the front. Fine. I'm calling a method called insertFront. So before inserting, what should I do? Check. I have to see whether it's full or not. If is full. So here size is 2. So it returns false. Else. Okay. Size is 2. Capacity is 3. So it returns false. I'll come here. Now what I have to do? I have to insert the element at the front, right? So I have to check. Is full. I have checked that now. I'll go for else. Beginning is taken care by the variable called head. So head is equal to, okay, as this is a circular queue, I have to do modulus capacity. This is fine now. Remember, I am going to insert in the beginning. Okay, but I have to check this index value where it is free. So for that I have to give head is equal to head plus capacity minus 1 because of the index value starts from 0. What is my head value? Head value is 0. Already I have element in the head. So 0 plus 3, that is 3. 3 minus 1, 2. 2 modulus 3 is still 2. On the index value 2, I am going to insert the value called 3. Okay. So here what I will be doing? A of head is equal to value. So as pictorial representation, so I will be inserting 3 in the beginning of the element. So now I will be inserting 3 here. Done. I have inserted 3. But as per array on the index value 2, I am inserting. So what is my head value now? Head value is 2. Because 0 plus 3, 3, 3 minus 1 is 2. 2 modulus 3 is still 2. So A of head on the index value 2, I will be inserting and then I will increment my size value by 1 which becomes 3. Done. After this, size value has to be incremented. Then I will return true. See, I have returned true. I have inserted 3 elements. Again, I am calling the method called insertFront. I am trying to insert the value called 4. So again I'm calling this method, I'm checking is full. See, size value is also 3, capacity is also 3, which means the DQ is full. So it returns true. When it returns true, states that the queue is full, I cannot insert element further, so it returns false. See here, it returns false. Done. Next, getRear. So what is the meaning of getRear? I have to get the last element of the DQ. So I'll go to the method called getRear. So to get the last element, so front is taken care by head, last is taken care by rear variable. So for that, first I have to check whether is empty. If my queue is empty, I have to return -1. If it is not empty, I have to return the last element. So A of rear. I said tail, not rear, tail. Okay. So for that, I have to check whether my queue is empty or not. How come I can know whether my queue is empty? If size is equal to 0, it is empty. Actually, here size is not equal to 0. It is not empty, so it returns false. So I'll go to A of tail. Tail value is 1. A of 1 is 2. So 2 is the answer. I have got 2. See, when we see in the array, it is not the last, but when it is in the representation, 2 is the last element. That's why I have separated the actual array, how it is stored, because in this array, insertion is happening in the beginning, deletion is happening in the beginning. Insertion is happening at the end, deletion is happening at the end. So let's confuse with this. That's why I'm taking separately the representation. So 2 is the last element, rear last element. So 2 will be printed. Done. Next, I'm checking whether my queue is full. The next one I'm checking is queue is full or not. So I'll go to the method, size is 3 and capacity also 3. It returns true. So queue is full. So it returns true. Fine. Next, deleteLast. deleteLast. Okay. I'll go to the method called deleteLast. So here, in the representation, if I see, this 2 has to be deleted. Okay, we'll see this now. deleteLast. First, I have to see whether my queue is empty or not. If my queue is empty, I cannot delete any element at all. So for that, I'll be checking if is empty. If my queue is empty, I cannot delete any element. So I'll return false. Deletion is not possible. If it is not empty, what I have to do is tail is equal to tail -1. I can say like this, tail plus capacity -1 modulus capacity. See here, what is my tail value? 1. 1 plus 3, 4. 1 plus 3, 4. 4 minus 1, 3. 3 modulus 3, 0. Okay. Now tail value becomes 0. Now tail value becomes 0. And my head value is 2. Okay. After this, I'll decrement my size. Now how many elements I have in my DQ? 2 elements only, because 3 minus 1, which is 2. 3 minus 1, which is 2. Now I have only 2 elements. That one element, this is head is pointing. Another one is tail is tail is pointing to 0 and head is pointing to the index value 2. Tail and head. Now the DQ has only 2 elements, so it is considered with 1 and 3. That's all. It is considered with 1 and 3. This 2 is not considered. Now the size of the DQ is 2, so we have only 2 elements. Okay, this 2 will not be considered at all, because when I go for the representation, it's easy for you to understand. See, now this is the representation. I am deleting at the last. So which will be deleted? This 2 will be deleted. 3 and 1. So 3, that is in the beginning, 1, that is at the end, tail. This is array, representation is this. So that will be easy for us to understand. This 2 will not be considered. Don't confuse with this. That's all. I have deleted at the last. Next, insertFront. Again, I'm trying to insert element at the beginning. So first I'm checking whether my queue is full or not. Actually, queue is not full because size is 2. 2 equal to 3, condition is false. I'll go to else part. Head is equal to head plus capacity. Head value is 2. 2 plus 3, 5. 5 minus 1 is 4. 4 modulus 3, 1. So now this index value 1 is free. So here I'll be inserting the element. Now head value becomes 1. Head value is 1. On the index value 1, I'll try to insert the element called 4. So I'll try to insert the value called 4. I'll try to insert the value called 4. Size will be incremented by 1. So size becomes 3. Now I am inserting the element at the front. So this 2 will be shifted here. So 3, 1, 4 has been inserted in the beginning. Because I am inserting at the front, right? So insertion is done. So I have written true. So true will be returned. See, true will be returned. Next I'll go for getFront. Now which is the front element of the queue? DQ 4. Now I have to get the value 4. Let's check. getFront. So for that I have to check one condition. Return. Check is empty or not. If it is empty, I have to return -1. If it is not empty, I have to give a of head. What is my head value? Head is pointing to the index value called 1. So 4 will be returned. A of 1. So a of 1, that is 4. 4 will be returned. See here. 4 is returned as the output value. So I've got the value called 4 because 4 is the front element of the DQ. See, in the representation we can get to know it very easily. 4. That is the front element of the DQ. So here I have almost filled all the methods. One method is missing. There is deleteFront is missing. So let me write the logic for deleteFront also. So first I have to check whether it is empty or not. So if is empty. So if it is empty, what I have to do? I have to return false. If it is not empty, I have to go to head is equal to head plus 1 because deleteFront, front is taken care by the variable called head. So head is equal to head plus 1 modulus capacity. Why we are giving +1 for head? Because head means beginning. I am trying to delete from the beginning. So head is equal to head plus 1 by capacity. Then size value has to be decremented by 1. And then I'll return true saying that the relation is successful. That's all. Let me run the code. Okay, there is a return statement. Okay, where is line number 69? Okay, here I have to return true, right? Once after the deletion is done, I have to return true. That is why it was showing error earlier. Let me run the code now. Yes, it passes the test cases. Let's submit the code. Done. That's all.